Welcome to the video lecture on the topic wind power plant. Myself, Dr. C. Sridevi, Assistant Professor, PG and Research Department of Physics, Sri Sharda College for Women, Autonomous, Salem 16, Tamil Nadu. Outline of the presentation. Need of renewable energy, wind turbine, classification of wind turbine, performance of wind turbine, conclusion. Need of renewable energy. Energy is the primary source of the development of the country. Country's economy, which primarily depends on energy. World energy consumption increases day by day. Around 70% of the electrical energy generation depends on fossil fuels. Fossil fuels generate greenhouse gases like carbon dioxide, methane, nitrous oxide, nitrous dioxide, carbon monoxide and many other gases. These gases affects the environment. Environmental changes include climatic change, rise in sea level and rise in the temperature of the land surface. In order to prevent this environmental effects, we move on to renewable resource. What is renewable resource? Renewable resource is an energy source that cannot be depleted and which is self-replenishing. Renewable resource also produce clean energy, less pollution, no greenhouse gas emissions. Examples of renewable resources are solar energy, wind energy, biomass energy, hydro energy, geothermal energy, tidal energy. In this, I have chosen wind energy. Indian energy scenario, current energy status. Around 35% electricity generation by using coal, that is fossil fuels. Around 23% of energy generation by using natural gas, 10% by using nuclear power, and 16% of electricity generation using solar energy, 3% using hydroelectric power, 5% using wind energy, and 2% using oil, and 2% using biomass, and 0.35% using geothermal. India is the third largest energy consuming country in the world. India stands fourth globally in renewable energy installed capacity, fourth in wind power capacity, fifth in solar power capacity, wind energy. People have been harnessing the wind energy for a long time. 5,000 years ago, ancient Egyptians made boat powered by the wind. In 200 BCE, people used windmills to grind grain in the Middle East and pump water in China. The wind is formed due to the sun's unequal heating of the earth's surface. Why wind energy? Wind is freely available, environmentally friendly, renewable and no pollution. Applications of wind energy. Wind energy is used for grinding grains, ship propulsion, grain cleaning, water pumping, kite flying, electricity generation. What is wind turbine? A wind turbine is a device that converts kinetic energy of a wind into electricity. It does opposite as that of the ventilator and fan. The working principle of a fan is that electricity is used to create a wind, but a wind turbine does the opposite. Wind turbine uses kinetic energy of a wind into electricity. Working principle. It works on the aerodynamic principle. Aerodynamic operating principle of a turbine blade is similar to the wings of an aeroplane. Here, There is pressure difference between upper surface and the lower surface of this blade. Because of this pressure difference, this blade rotates. Wind turbine turns the wind energy into electricity using aerodynamic force from rotor blades, which works like an aeroplane wing. When the wind flows across the blade, the air pressure on the one side of the blade decreases. At the upper surface, the air pressure decreases and the lower surface air pressure increases. Because of this pressure difference, this blade rotates like this. This force lifts the stronger the drag and causes the rotor to spin. Wind turbine and its components. So here, these are the components of wind turbine. One is the blade. Number 2 is the nacelle. Number 3 is the rotor. Then 4, tower. Then next is anemometer, generator, and this is the gearbox, and this one is the system. Blade. Blade is similar to aircraft wings. They collect the wind and transform the kinetic energy into rotary motion, which rotates with a rotation speed between 10 rpm to 25 rpm. Nacelle. It is the heart of the wind turbine, this one, nacelle. And it contains main shaft, gearbox, generator, anemometer, and yaw system. This nacelle contains anemometer, generator, gearbox, yaw system. What is anemometer? Anemometer is a device which measures the wind speed and direction to control the turbines and align them towards the wind for best possible performance. And next one is generator. Generator is a device which is an electrical machine that transforms the rotation of the rotor into electrical energy. The next one is gearbox. Gearbox increases the rotor rotation speed to that necessary for generator to operate. Next one is yaw system. Yaw system orientates the wind turbine. Then third one. What is third part? Third part is rotor. Rotor is a part of the wind turbine consisting of the hub to which the blades are fixed. And this one is the rotor. Rotor contains the hub. In this, the 3 blades are fixed. The diameter of this rotor is around 90 to 150 meter. The next one is tower. This one is tower. Tower is a structure that supports the nacelle on the blades. This is the tower which supports the nacelle and the blades. The average height of the tower is 80 to 115 meter. The next is cable duct, which is the wire which connects the tower with the transformer. Then transformer is connected to the grid. From the grid we take the electricity, and also from the grid the electricity is distributed various parts of the system. Next, classification of wind turbines. Based on the axis orientation, wind turbines is classified into 2 types, horizontal and vertical axis wind turbine. Based on the number of blades, the wind turbines are classified into 1 blade wind turbine, 2 blade, 3 blade, and multi-bladed wind turbine. Based on the location, the wind turbines are classified into onshore wind turbine and offshore wind turbine. Based on the power control, we can classify it as stall, variable pitch, controllable, aerodynamics. Based on the surface, yaw control and orientation, it is classified as driven yaw, free yaw, and fixed yaw. Based on the rotor position, the wind turbine is classified into upwind wind turbine and downwind wind turbine. Based on the transmission, wind turbine is classified into with gear wind turbine and without gear wind turbine. Based on the type of hub, wind turbines are classified into rigid, tethered, hinged blades, gimbaled wind turbines. So this is the schematic diagram of horizontal axis wind turbine and vertical axis wind turbine. Out of several classification, we are commonly using horizontal axis wind turbine and vertical axis wind turbine. So in the horizontal axis wind turbine, the blade rotates horizontally. The vertical axis wind turbine, the blade rotates along the axis of the turbine. So here these turbines contains single bladed, double bladed or three bladed one. Difference between horizontal axis wind turbine and vertical axis wind turbine. They have horizontal rotor shaft with blades that resemble an aeroplane propeller. But vertical axis have vertical rotor shaft. Here horizontal rotor shaft, in vertical axis vertical rotor shaft with blades rotate around it. Horizontal axis wind turbine are suitable for both small scale residential installations and large utility scale wind farms. They capture wind from any direction and are often used in urban environment. A typical horizontal axis wind turbine can generate electricity with capacities ranging from 1 kilowatt to 10 megawatt. In vertical axis wind turbine are typically smaller with capacities ranging from few hundred watts to few megawatts. In 2022, global horizontal axis wind turbine installations contributed to over 97.3% of the total wind power capacity. These turbines account for about 5% of the global wind power capacity in 2022. Why this very low percent? Because few vertical axis wind turbines are in use today because they do not perform as well as horizontal axis wind turbine. Performance of wind turbine. Wind speed largely determines the amount of electricity generated by the turbine. The limits range are known as cut-in speed and cut-out speed. And this one, we have to operate wind turbine between these two ranges. This is lower limit and this one is higher limit. This is lower limit is cut-in speed, higher limit is cut-out speed. In between cut-in speed and cut-out speed, you have to operate wind turbine. Then only it produces very high power. What is cut-in speed? Cut-in speed is the point which wind turbine is able to generate power. Cutout speed is the point the turbine must be shut down to avoid the damage of the equipment. Cut-in speed is the generator which starts to generate power. Cutout speed is the point where the generator to shut down to prevent the damage. In between this region, we have to operate the wind turbine to generate maximum power. Cutout speed is the point at which the turbine must be shut down to avoid the damage to the equipment. Cut-in speed and cutout speed designs and size are decided on prior to the construction. Air density. Power output is related to local air density, which is a function of altitude, pressure and temperature. Dense air exert more pressure on the rotors, result high power because power generated, power maximum is equal to 1 by 2 rho A C I cube, where rho is the density of the air, A is the area of the blade, Ci is the velocity of the wind. For example, if wind speed doubles, power output increases 8 times because Ai cube rho equal to Ci cube. When Ci increases 1 times, Pmax increases thrice. Dense air exert more pressure on the rotor, results high power. which is based on this equation. Next, turbine design. Wind turbines are designed to maximize the rotor blade radius, maximize the power output, because power maximum is equal to 1 by 2 rho a c cube. When increase the density, we can increase the power. By increasing the area of the blade, we can increase the power. By increasing the velocity of the wind, we can increase the power. So power output depends on all these three parameters: density of the air, area of the blade, and velocity of the wind. However, larger the blades require more space and high wind speeds to operate. Performance of wind turbines. Wind turbine performance is based on these three factors. One is power coefficient, tip speed ratio, solidity. Power coefficient. Power coefficient is power delivered by the turbine by maximum power available to the turbine. But maximum power available to the turbine is equal to Pmax equal to 1 by 2 rho A C cube, where Ci is the incoming wind velocity, A is the area of cross section of wind stream, rho is the density of the air. Power delivered by the turbine with the efficiency of 59.26 P equal to 8 by 27 rho A Ci cube. Actual efficiency of the wind turbine may be less due to the frictional losses in the rotor, gearing, and mechanical coupling loss in the generator. Actual wind turbine, the efficiency in the range of 35 to 44%. Next is tip speed ratio. Tip speed ratio equal to blade tip speed by free stream wind speed. Solidity gamma equal to blade area by swept frontal area, which is equal to Nc by R. N is the number of rotor blades, R is the radius of the blade, C is the mean chord length. Wind turbine capacity. So when we, based on the previous discussion, when we change the diameter or when we change the structure of the wind turbine, we can increases the power maximum power. So when we year by year, the power capacity, maximum power capacity obtained from wind turbine is increasing by increasing the rotor diameter and also hub height. This is the hub height and this one is the rotor diameter. By increasing rotor diameter as well as the hub height, we can increase the power capacity. In the year 2022, we obtained 3.5 megawatt power by developing larger wind turbine. So this is the structure of wind turbine. You see this in the year 1900, 0.2 megawatt power, 2000.9, 2010 1 megawatt power, 2016 6 megawatt power, 2035 17 megawatt power. You see this, the size of the wind turbines increasing day by day. While we increase the size of the wind turbine, we can develop the high power, but there will be some limitations on this. What is that limitation? That is transportation and installation challenges. If the size is too large, we can't be able to take those parts for longer distance, and installation is not easy. So transportation and installation of large turbine blades for land-based wind is not easy since they cannot be folded or bent once constructed. Turbine tower diameters are difficult to transport since they may not fit under bridget, bridges or highway overpasses. Advantages. Wind is an infinite source of electrical energy. Wind is freely available source, so we can generate electricity with free of cost. It is cost effective source as the running cost of the wind power plant is very less as compared to the thermal power plant. It is environmental friendly. Wind power plant does not emit any carbon fuels or any carbon emissions. So this plant helps to reduce carbon emission. Challenges. The main disadvantage of wind turbine is inconsistent because the wind is not consistent. One day we get larger amount of wind, another day we get less amount of wind. So we the generation of electricity is not consistent. It differs because availability is not uniform in all the day. Capital cost to install a wind turbine is very high to build the construction and foundation. Site selection of wind turbine is difficult. It must be located at which the wind is constantly available. Conclusion. Converting to renewable energy will not only better sustain the world's rapidly growing population, but it will also provide a cleaner, healthier environment for the generations to come. So this is energy change. We are changing the renewable source by year on increasing. This is the very good trend. Thank you. References.